Hey everyone, welcome back to the Physics Unit 1 videos. In this video, we're going to be looking at something that we call projectile motion. So when we're solving problems that involve launching an object at an angle, we might have to use our sine and cosine ratios to find our vertical and horizontal displacements. So what we do then is that we proceed with one of our kinematic equations that we had studied earlier. And in addition to this, one thing to note is that when we work with projectile motion, we must describe the angle that is launched in terms of the angle of elevation. So our angle of elevation starts from some sort of horizontal level, and then we measure that angle counterclockwise. So we might say that this might be 30 degrees from the horizontal. But one thing that's really important with projectile motion is that we must be working with either just vertical information or horizontal information. So whether or not we're working with speeds, distances, displacements, any of that kind of stuff, we need to keep the two separate. Vertical belongs with vertical, horizontal belongs with horizontal. So you have to be sure the two are separate. You can't just interchangeably use each information and mix them up in equations. So be very careful to keep those separated. So here we're going to be looking at example number 1 from the objects launched at an angle section in your notes. So baseball players often practice their swing in a batting cage in which a pitching machine delivers the ball. If the baseball is launched with an initial velocity of 22.0 meters per second with a 30-degree angle, and the player hits it at the same height from which it was launched, so how long is the baseball in the air for on its way to the batter? So, and one thing that I like to do with these types of questions is that I always like to draw out a little diagram of what's going on. So maybe this point right here is where we're going to be starting to launch this ball after once it exits that machine. And then it's being sent over to the baseball player. And this angle here is 30 degrees. And here's our little baseball player standing right there. So here we want to know how long does it take for the baseball to basically reach the batter. So here we're looking for our change in time. One thing that we do know here is that we have this angled velocity of 22.0 meters per second. And that's about all that we're given in this question. So this doesn't sound like we have a whole lot to work with. But believe it or not, we can find a lot of information just knowing the velocity, your initial velocity, an angle, and that's it. So what we're going to do here is that we can either find our horizontal or our vertical information. And typically what I like to do is I would recommend you guys should work with your vertical information, because there's also something that we know about vertical, motion, is that there is an acceleration pulling down an object at a rate of 9.81 meters per second squared. So that's pretty much always your first step, is to work with your vertical information. And so in order to work with your vertical information, you need to know a vertical velocity. So looking at here, if we were to create a right triangle with our with this angled speed, you have 30 degrees. That speed was 22.0 meters per second. By finding this vertical speed, we're finding this side going up and down, which is our opposite side to the angle, which tells us that we're going to use our sine ratio to help solve for this. And please note that this here is going to find our initial vertical speed, but we know that at other points as well, that might not be the case. So this one here, you're going to find the initial velocity in your vertical direction, but because of gravity, we also know that, say, at our maximum point here, our final velocity might be, say, 0. So this one here finds your initial velocity. All right, so plugging in our information, we have sine of 30 degrees is equal to your opposite, which we don't know, divided by your hypotenuse, which is 22.0. I can write sine of 30 over 1, so I can use cross multiplication to solve. So essentially my x value is going to be equal to 22.0 times the sine of 30 degrees. Then you can go ahead and plug this into your calculator. So we have 22.0 times the sine of 30. That should give us a value of about 11.0, and that our units will be meters per second. And that one there is still following sig figs because we have 3 sig figs in our 22.0 as well as say in our answer there. So now we have a vertical velocity, and sorry, that one there is our initial one. So as long as we have some sort of vertical or say horizontal information, now we do have enough information to find our time. So I will start by writing out everything I know about my vertical information. So I know that my initial speed, so my VI, or that velocity, is 11.0 meters per second. And we also know that we have an acceleration of 9.81 meters per second squared down. And there's one other thing that we know. Looking at back to our example, if we're looking at our change in our total vertical displacement from the start to the end, it hasn't gone up or down just comparing its starting and end points. We know that it did go up, it came back down, but the overall change in height is actually 0. So we know that that change in displacement is equal to 0 meters. So this here is actually enough information to find our change in time. And so with that, we can use one of our kinematic equations to find time. And that example there, or I guess the equation there, is that second one from your notes, which is delta D is equal to VI times your change in time, plus 1/2 times your acceleration, times time squared. So here's step 2 if you want to give it some steps. So here our total displacement was 0. So that's equal to your initial velocity of 11.0 meters per second times the change in time, plus 1/2 times, and this one here is going to be very important, is that our acceleration here is going to be negative because it's pulling it down, and we know that initial velocity would be pushing it up. So we have to make sure we have those negatives in there to indicate the different directions. So I'm going to simplify this right-hand side here. I'm going to multiply 1/2 by that negative 9.81. So 1/2 times negative 9.81 is negative 4.905 times delta t squared. And what I'm going to do here is that because we have two terms here and both of them have variables, I'm going to move my delta t to the other side, and then I can divide each side by delta t to get it by itself. So here I'm going to subtract by 11.0 delta t. And so from there I have negative 11.0 delta t is equal to negative 4.905 delta t squared. So now one thing that I want to do is I don't want to have this delta t squared. I don't have delta t on each side. So what I want to do is I'm going to divide by a delta t on each side. So that actually gets rid of this square and gets rid of the delta t on the left side. So I have negative 11.0 is equal to negative 4.905 times delta t. So notice how we don't have that square anymore, and we only have one variable in total in our equation, which makes our life a lot easier. So now what I'm going to do is I want to get rid of this negative 9.05, so I'm going to divide it on each side. So that cancels out our negative 4.905 on the right side, so I'm left with just delta t. And then plugging this into our calculator, we should get a total of 2.24 seconds for our time. And that one there is accounting for sig figs throughout this whole section here. So if you guys just want to kind of keep track of that, here we have 3 sig figs for 11. We don't have to worry about sig figs for this because these are given values. So when we're dividing here, we still have our 3 sig figs, so our answer here should have 3 sig figs as well. And also, if you're a little bit confused about how we get the time or our units of seconds for time, just note in your speed or your velocity and your acceleration that you have seconds in your units, so your time here will also have seconds in your units. And then one last thing to note here is that this one here was a word problem, so we do actually have to answer this with a sentence. So we could say that the baseball was in the air for 2.24 seconds. So that is everything here for this video. So if you guys have any more questions, make sure to shoot me a text on Remind 101, or you can come see me in class. And thank you guys so much for watching.